I guess let's just go in order.
Yeah.
And then I'll talk to you about my problems when I get there.
Okay.
Hang on.
And I, just to mention, I mean, I went through this pretty quick, so there could be a lot of things that I did wrong on here. I felt pretty good about it, but that doesn't mean much, you know.
No problem. Sorry, I'm just saying this last text. Okay, so let's just go through it and we'll just see. But I feel bad because I feel like I'm not a very good balancing board because I'm really hesitant myself. But like I said, I haven't had time to like sit down and concentrate. I wish I could go to the library. That sounds amazing.
Right, yeah.
I got dinosaurs in the background growling. Okay, so number 2, what did you put?
So for number 2, oh, sorry, hang on. Number 2, I put, where am I? I put B.
I put we are 90% confident that the true mean heart rate is between 45 and 105.
Uh-huh, yep.
Is that what you got?
Yep, that's what I put.
Okay. Okay, and then number 3, I put, let's see, let me remember these questions. I put no, the distribution of the mean of each sample is not normal size, and the sample size is not large enough because it was under 30.
Oh, okay. I put down D, but let's see. Well, so it's 20 females and 15 males, so we're not adding those together. They have to be counted separately then? Is that what it's saying?
That was my understanding. Let me read what the...
I guess that makes sense, yeah.
Yeah, I have the central... Okay, I'm not telling again right now, Brody. Upstairs, Liam, upstairs. It's not an option. Taryn, Madeline, upstairs, not an option. And I have an extra body tonight. Okay, central theorem says, you have observed in the situation that if the sample size is large, which we defined as 30 and over, right?
Mm-hmm, right.
The random variable X will be approximately normally distributed. In other words, the sampling distribution of the sample mean will be approximately normal if the sample size is significantly large. But I was thinking, because we're comparing the two, right?
Mm-hmm. Yeah.
And so, since both parties don't have a significant pool to compare to, or a large pool, that's why I put no. But I could be wrong.
I think you might be right. I didn't see it that way, but I think you might be right there. So I'm gonna mark mine. I'm just gonna put 3D, and then if we need to, we can come back to it. But I'm gonna put no. The distribution of the mean. So I'll put A, choice A, and we'll roll with that one.
Okay. And then, okay, so 4 says, of the 4 types of confidence intervals, this is what always messes me up. Listed below, which one is appropriate for this experiment? And I said confidence interval for mu when sigma is known.
So I put down C, confidence interval for the difference of means using independent samples. And the reason why I did that is
2 groups.
Because we're doing 2 groups, exactly. And the groups are independent because they don't rely on each other. So I put down C for that reason.
See, that's the thing. Like when I can talk it through with someone, it makes sense.
Isn't that a miracle?
The problem is I don't have anyone to talk it through when I take a test, right?
Yeah, that's kind of how I feel with some of my classes. I'm at the point now where I'm almost graduated, and there's material that
senioritis bad, huh?
Yeah.
I'm almost a senior. I'm like 5 credits shy, and so even though I still have a whole nother year, I still feel this way. I still feel like that. Anyway.
Yeah.
Okay. So number 5. Let's see. I put none of these answers.
I said obtain the balances of 90 bank customers rather than 30, but that was off of a limb. So do you?
Let me read through it really quick, and I'll tell you why. Go upstairs. You will lose privileges if you don't listen. No. Go upstairs. A researcher is sample of their customers. Smaller margin error than 95%. Okay, so I automatically took A and B out because those just didn't, why would those apply? 30 is sufficiently large though, right? Haven't we defined 30 as a large?
Mm-hmm.
So, what, I guess maybe the rationale on what you picked, why increase to 90?
So all that it's asking right now is which of the following would produce a confidence interval with a smaller margin of error. And so we're talking about even if it's infinitesimally small, you can still get a smaller confidence interval if you have, if you've got closer numbers. Does that make sense?
Right. So that's more data gives you closer.
Mm-hmm. So even though it doesn't make a huge difference to have 90 as opposed to 30, they're both normal. But if you do add more people, you are going to get a smaller gap. It's very, very small, but you're still going to get closer numbers, if that makes sense.
Yeah, it does. I remember that in the reading too. And we talked about this before.
Yeah. So I want to stick with that one.
Yeah. I think you're good.
Now, question 6, I didn't do this one. 6 through 9, I ran out of time, but I have the rest.
Okay. So, oh, great. I hope I did this right. So 6, I did determine margin of error of 95% confidence interval. I did the z times sigma over n squared, the square root of n.
Okay. Yeah.
So I did 1.96 times 2 over the square root of 4. And I guess maybe where I was hesitant is 4 really my number. It says she randomly selects 4 drive shafts. So I'm assuming that's my n.
Yeah, that's got to be. It has to be.
So because 2 divided into the square root of 4 is 2, the answer still came out to be 1.96. Does that make sense?
Yeah. Yeah, that makes sense.
So I got 1.96 for that.
Okay.
I hope it's right.
It should be. So you did 1.96 times what was the standard deviation?
2 over the square root of 4.
Yeah. Yeah, that should be right.
Okay.
So 1.96. I think that's right.
Okay, so 7, the lower bound. So then I did the formula for the lower bound.
Mm-hmm.
So I took the lower bound, which was, or the mean, 1,000 minus, for the lower bound, 1.96 divided 2 divided by the square root of 4, and I got 998.04.
Okay.
Does that seem like I'm using the right formulas?
Well, let's see. To get the lower bound, it is the point estimate. And point estimate is the same thing as your mean. So I think what you have to do is you have to take 1,000 millimeters minus the margin of error.
So the 1.96.
I think. Well, is that right? Okay.
I don't know if you can see. This is my. Let's see if you can see that.
I'm pretty sure that's it.
Does that make sense? Can you see that?
Let me.
Is that coming in backwards at you?
Oh no, I'm seeing it. So it's 1,000 minus 1.962. Yeah, that looks right. Yeah, that looks right.
Am I doing those the right way?
I think so. Well, actually, wait, hang on. Let me get my calculator out. So it's 1,000 minus 1.96 times 2 divided by 2. So I mean that's right. 1. So basically, you're taking 1,000 minus 1.96.
Right. Which I got 998.04.
Okay. Yeah.
Is that what you got?
Yeah. Okay. So that should be right.
So then I did the same thing, but for upper bound. So I added 1,000 plus 1.96. So I got 1,001.96.
1,001.96.
Yeah.
Okay. Yeah, that should be right.
Okay. So then number 9, I had to go back and review all these formulas. Gosh, man. I wish it wasn't a cumulative test. I wish it was just the section. This one, I use this formula. Did you see that on the bottom?
Let's see.
Because we're looking for the n, right?
1.96 times 0.01 over 0.0001. Is that what I'm looking at?
Yeah, the very bottom one.
Let's see. Let me look at my sheet here. So we're trying to find
how large should n be so that the 95% confidence interval for mu has a margin error of 0.0001.
Okay, yeah. So margin of error is equal to 0.0001. So that's the margin of error. So that's equal to, and this is 95%, so it's 1.96 times, and we don't know n, is that correct?
Yeah, we're searching for n.
Okay, so square root of n, and then we do know the standard deviation, so 0.01 grams. So you just switch that stuff around there, and let's see. Usually I square everything, 0.96, so that way I just have n by itself. Let's see here.
I got 384.
Okay. So n is equal to 1.96 squared times 0.01 squared
Divided by
0.0001 squared. Is that what you did?
Yep.
Yeah, that's right.
So 384.
384. Okay. Yep.
Okay.
That feels pretty good.
Okay. So then, did you do 10?
Yes, I did. Yep. So I put D.
So did I.
Awesome. Okay.
Okay.
Question 11, I put B as in boy.
So did I.
Okay, awesome. 12, I put yes, C.
So did I.
Okay. 13, I put A.
So did I.
Awesome. 14, I put A.
So did I.
Okay. 15, I put D.
I put C.
Okay. Let's see.
Hey, Dakota, do you mind if I step away for just a second?
Oh yeah, that's totally fine.
Thanks. I'm sorry. When I get into class, they know it's like I can't do anything, so they start killing each other.
Oh, that is quite all right. You know what? When I was in high school, my mom graduated with her master's when I graduated high school. So when I was going through junior high and high school, she was going through college at the same time. And
Oh gosh.
yeah, it was
to be done before they're all in 3rd grade. So
there you go. Yeah, but
my fault for doing it back.
It was a struggle for her, and she didn't have little ones, so
yeah, I'm sure.
That's okay.
Okay, so I put so the okay, so we're saying, let me just define where I'm at here. Is this evidence is higher than advertised? So we didn't have, okay, so what the null hypothesis is saying is that the mean is greater than 1.5, right?
So the null hypothesis is like, the way I see it is it's like, this is what the conditions normally are like. And we believe that it's something different.
Right.
Does that make sense?
Right. So this saying mean is 1.5, but alpha, is that what it's called? The fish?
Let's see, which one are we on? Are
The
we
level
on?
15?
Oh, I'm on the wrong thing here. 15.
Did I go to the wrong one? Did I go to the wrong one?
No, we're on the right one, I'm pretty sure. It's just, I think, what did I do?
So the level of significance is 0.05.
Oh, no, I think we did do something. I think we were on question 10.
Gosh, what did I do? Mine must have been mixed up.
Well, I think
Oh, yeah, I did. I mixed them up.
Brightspace has a tendency to move your play sometimes when you're looking at it.
Okay, so 10, I put D.
10, I put D. Yep.
Okay, we were just looking at different questions, so.
Yeah.
Okay, so 11, did we do these? We did these already.
Maybe we did. I am so confused.
B,
So
12
B, 12 is C, 13 is A, 14 is A. Oh, okay. So I guess we were on 15. Never mind.
Okay, you're okay.
So I'm not sure what I did. Anyway.
Okay. So 15 is, okay, so it's saying that the level of significance is 0.05, but the hypothesis says that mu is 1.5, so it's more, right? So I was reading the rules that says if alpha is greater, then you fail to reject the null hypothesis.
Let's see. So what were your numbers again? Let's go through and look at them.
Gosh, I can't concentrate with my kids. I'm so sorry.
Oh no, I'm
I was gonna
sorry.
I was gonna call you and see if you could maybe meet at 9, and I'd put them all to bed.
Well, it's totally cool. I'm good for the night. I don't have anything else. So.
Well, do you care if I put him to bed really quick and then we meet back up?
Sure. No problem.
Honestly, Dakota, are you okay with that?
No, I promise I am.
Okay. We can meet back at 9 o'clock.
Yeah, let's do that. We'll start on question 15 when we come back, and yeah, and if you need more time, just send me an email or just whatever. You can text me too.
You're amazing. Thank you.
You bet.
Bye.
Okay, bye.